So we want to review 8.4 is number 51. It says in kind of funky words, this is really a word problem. So my first step should be either read it or don't panic, right? Preferably don't panic, then read it. So I sort of synthesized a little bit, but roughly they say give a function for area in terms of W using this figure. And then part B says find the maximum area. Cool? Okay, so after I've not panicked and read it, what's my next step? Yeah, try to draw some kind of picture. They already did that step for me, right? So now what do I need to know? What do I need to do? I just try to write an equation, right? Okay, so what word is cluing you to what equation to write here?
Area.
Yeah, this word area, right? So when you see the word area, what do you think?
Length times width.
Oh, cool. This is a rectangle, so the area is length times width. So the area is length times width. Is there a better way that I can write that? Maybe given this picture? Yeah, W is probably the width, right? What's this thing?
The length.
That's the length. So I could probably write area as a function of W, right? Is length, 20 minus W times W. Is that right?
20 minus W purposes.
Yeah, I want that whole length times that whole width, right? So this whole thing needs to be multiplied. That's really an order of operations problem, right? Okay, so now that I've got area as a function of W is this thing, what do I do? Okay, we could distribute, right? This is really the answer to, you guys see that? That's already the answer to part A. So now I'm looking for maximum area, right? So to maximize a function, I really only have one tool. What is it? Okay, let's multiply it out and see what we get. How about that? So area as a function of W is what?
1 minus W times W.
Okay, which multiplied out is?
20W minus W squared.
Okay, 20W minus W squared. Okay, now what do you do with this? Yeah, there's a sort of a temptation to try to solve this thing, right? You guys see that? Why can't I solve this? Why is solving not a good idea? Yeah, really, this is just telling me about a rule, right? There's no number on this side. This is just the area in terms of W is given by this formula, right? So if I try to fiddle this around and solve it, there's really no other side to kind of manipulate, right? So what I would like to do is find out when is this biggest, right? You guys see that? They ask for maximize area. I have area in terms of W is written this way. So how about this? Graphically, what is this thing? You guys all recognize that? It's a parabola and it's pointed down and probably shifted around, right? So at the very least, I know this thing looks like, here's the W axis and there's this parabola. This is my area in terms of W. You guys see this? Does it have to cross that axis? I don't know, not with the information I know. Maybe not. So what am I looking for on this thing? I want to maximize area. Where's the area direction in that picture?
Above the W axis.
Yeah, you guys see that? This is sort of the area axis, right? Really, that's the y-axis, right? But these points are a W, comma, area of W. You guys all with that? So I want to know when the area of W is biggest, right? So that's asking what's the highest this thing ever gets? So now I'm looking for a vertex. Yeah, so I want to use the vertex formula. When you see this maximize thing, or even the word minimize, you should really think vertex. That's really the only tool we have so far. So if you guys did this for now, it'll work. Maximum, think vertex. Later we'll have other formulas to give us maximums, but for right now the only one we have is this vertex thing. So what's the vertex of this guy? Okay, so I need to remember the vertex is above negative b over 2a, right? Is it an x in this case? You guys all see that? It's a w in this case, right? And what are the a, b, and c for this guy?
-1, 20, and 0.
C is 0, and also I don't care about c, right?
Yeah.
You guys see that? It's not in my formula for vertex. Really, I don't care about it. That's me not caring where this w axis lies. Okay, so I remember that the vertex is above w is negative b over 2a. So the vertex is above w equals what? Negative 20 over 2 times negative 1. So that's 10.
That's the x coordinate.
Yeah, and this is a w coordinate, right?
W.
So my vertex up here has coordinate 10, comma,
So you put that number back into the solution.
10, comma, I don't know. I need to know what the y is, right? What's the y on a graph? You guys remember this? The points on the graph are a input-output pair, right? So my input's 10. Where do I get the output?
By plugging it back into the area function.
Yeah, I just plug it back in here.
Yeah.
You guys see that? What do you get when you plug 10 in here? Or in here, right?
I think we really should put it in here.
200 minus
It doesn't matter, they're
100.
equivalent.
200 minus 100.
200 minus 100 is
100.
100. So my vertex is at 10, comma 100. So what's the answer to my question? Find the maximum area? You guys playing along with this, or are you a little lost? Show of hands for totally lost. Okay, who's just early in the morning? Most of you? Okay. So we'll address totally lost in just a second. So once I found this vertex at 10, comma 100, what's my maximum area they're asking me for?
Plugging in the values you have for W, so you should maximize each side.
I've got this. It's sitting right here. So I found the vertex. The vertex is at 10, comma 100. That's the vertex of the area function, right? So points on the area function are a input output pair, right, on the graph. So this 10 is an input for the area function, and this 100 is an output for the area function. You guys see that?
100 on the other side. No?
You'll get 10.
Oh.
If you ask what input gives you the output 100, which is really what putting 100 in here does, you'll get 10. You know that because you put 10 in and you got 100 out. You guys see that? So what I'm trying to answer is part B, find the maximum area. So the area is the vertical on this picture, right? And I know the highest this picture ever gets, my parabola, is at 10, 100. So what's the highest that 10, wait, how high is 10, 100? It's 100 high. So the maximum area is 100. Because I'll see that the vertex is at that maximum. And when I want to know about the area, I'm asking what about the y coordinate for that vertex? So I just read it off the picture. So I can say the maximum area is 100, and then there are probably some units. So it's meters, and it's an area 100 meters squared. Guys cool with this? So part A's answer was the area is given by this formula. Part B's answer, the biggest number you can ever get out of that formula is 100 meters squared. You'll see that? The trick between the biggest number you can get out of that formula is at the vertex, right? And then I just need to know whether the thing I'm looking for is an input, right? What's the width that gives you that maximum area, or an output? In this case, it's an output, right? Because they're asking for the area. Is this, of course, the thing you care about in terms of building this? Yeah, you probably want to maximize area. But if you're going to actually build this, do you care what the area is, or do you care what the, or how to make it, right? So where do you get the width that goes with this maximum area? Yeah, it's 10. Why is it 10? Because that's the input that gave you that maximum output. You guys see that? Cool. Questions? Still totally lost, or are you okay now? Cool.
Can you do